history of the internet and the World Wide Web? I am. Thank you for asking. Okay, so we're going to talk about how the internet came to be. Varsha touched on this morning. I'll just give tiny bits more detail, and there's some detail on the slide. There are links to really good references that you can use when you do these short answers for your portfolio at the end of this presentation, okay? So we'll look at how the internet came to be, how the World Wide Web came to be, how technology and the web has evolved since its beginning, and how the World Wide Web works. So the what is the internet? It's a system. It's a network made up of systems and protocols that connect devices to each other over the globe. So there's a lot of cables involved. You know, we have physical machines connected to each other and connected to routers and connected to modems. That was router and modem together. Routers and modems. Connected, you know, into your homes and into your workplaces. And then, of course, we have wireless networks provided by routers and by satellites and modems. And it's grown, like, tremendously. And it really, honestly, hasn't been that long that it's been around, relatively speaking. I mean, it's, you know, happened in my lifetime anyway. It was first created, the internet was first created by the U.S. Department of Defense, basically, to defend the United States against nuclear attack from Russia after Sputnik was launched. The first satellite was launched by Russia. And, you know, Americans got really worried about being nuked from space. And so it was developed in response to that, to try to improve communication, intelligence communication between the various, you know, parties around the world who were looking out to make sure that we don't get nuked. So it was created by ARPANET at first, but grew over 20 years to a way of connecting scientists and researchers around the world. So that was NSFNet. So it started as a military endeavor, and then it somewhat quickly became something that was used by the science community to connect research facilities, first in the U.S. and then the U.S. to Europe, and then it, you know, it spread from there. Once it got taken hold of by the scientific community, it only took about 5 years before it spread to sort of the private sector, you know, where companies were like, hey, we should be able to use this too. This is a really good tool, and you shouldn't be the only ones who get to use it. So, and then of course it became a really profitable thing, and anytime that there's profit, especially in the U.S., anywhere though, then those things start to grow really rapidly. So, TCP/IP came around in 1983. Before that, there was a network control protocol, which ARPANET was originally based on. But once TCP/IP, and that was sort of made like really quickly. You know, you can imagine like engineers hacking something together because they were trying to get something working. It wasn't a very good, robust protocol, so it was replaced by TCP/IP in 1983, which is still used now. We still use those two protocols, TCP and IP. So, from 1969, which is before I was born, by the way, 1969 to 1990 is where we saw ARPANET develop, and then it sort of shut down, and NSFNet became the real user of the internet that existed at the time. So there's some more details there. I'm not going to read the slide. You can read the slide, and you can use it for your research. And then there's some links to where I got this information and some other places that you can look further if you're interested. From 90 to 95 is where we saw the kind of beginnings of privatization of the internet and the bodies, the standards bodies that oversee how the internet works and how it's managed and what protocols are used and what processes are followed. And then a bunch of commercial providers came into play. There were 4 network access points that were established in the U.S. and those initial commercial providers are talked about in one of those links and at the end of the slides. So by the end of 1995, there were an estimated 16 million internet users. We're going to look at some more at growth in a bit. So when NFSnet dissolved at the end of the 90s, the transfer of the administrative duties went from government to the private sector. So ICANN has the responsibility for the assignment of Internet Protocol parameters, oversight of the domain name system, allocation of IP addresses, and management of the root server system. It also acts as the Internet Assigned Numbers Authority, is responsible for the operation and evolution of the DNS system. There are a lot of organizations involved in management of the Internet since 1998. There's a link that takes you to go have a look at those. But it's pretty cool because there has been, from the start, this dedicated focus to making sure that everything is open, transparent, that globally people contribute to these organizations and have a say, so it's not, just one country or one small set of companies that dictate the way that the Internet evolves and how it's used. I'm trusting what I read here, that it's open and transparent. Who knows in reality, but I'm assuming that that's true. I've never been involved in any of those standards bodies, so I don't know the reality of it, but that's what they say anyway. So I'm going to be optimistic and trusting and perhaps naive and believe that this is true. All right, so the World Wide Web, which is different from the Internet. Okay, these two, we use those terms interchangeably, but they're two different things. The Internet is just the network itself, the physical network and the protocols and processes that we use to do things over that network. Okay, the World Wide Web is an information system that uses the Internet. One information system that uses the Internet, and what it allows is us to connect documents to each other over the Internet with hyperlinks. So so hypertext, of course, is an essential component of the World Wide Web, and it was invented by 4 different people within 5 years of each other, which is interesting. So it was something that was going to happen. Okay, so it was invented by different people for different uses right about the same time, and some of those people ended up working together to actually form, the sort of protocols and standards that we use for HTML in the World Wide Web today. So Tim Berners-Lee, Robert Callio, which I should know how to say that because it's French, but it'd be like Robert Callio, Douglas Engelbart, and Ted Nelson. So those are the 4 people who kind of invented hypertext at about the same time. So Tim and Robert worked together at CERN to develop the hypertext system that we think about today, that evolved to be used in the World Wide Web. Tim Berners-Lee also proposed a system, the system to communicate information among researchers first at CERN in the High Energy Physics Department to help share information across different networks. So at the time, CERN was using all of these sort of like disparate kind of machines and networks. They couldn't all talk to each other easily. It was a bit of a mismatch of there's the French words. I can't remember what they are. It's not even what it's called anymore, but they still use the acronym CERN. Yeah. It used to be called something that was the acronym for, but it's called something else now. So in 1990, Tim created the first web browser on a Next computer, which was like one of the first Apple computers. And it came with an integrated hypertext editor. And he deployed it on the computers, on his and Robert's computers at CERN, and that was the first web server ever created. So they communicated with each other over that web server, and then they presented it publicly at a conference in '91. Then Tim Berners-Lee posted a link to his web server and his very simple command line browser, he posted it for download in a news group. Is anybody here old enough to have used news groups like MIRC and things like that? Yeah. So when I first started using the internet, which was in the kind of late 90s, that's like what there was. There was like these command line news group interfaces. So you could like post, it's just text-based, all text-based. So you could post, text in these news groups, and you could subscribe to news groups, and then you could read what other people wrote. And there was like group chat functions and like, messaging, so you could like message each other, but it was all terminal-based. And I thought it was super cool, at the time. I was like, wow, this is awesome. And then there was AOL. And there was suddenly this graphical interface, which AOL pretty much did the same thing that the text interface for the news groups did, but it was like, with a graphical interface. But as soon as Berners-Lee posted the link to his implementation of a web server and line browser, they started popping up everywhere, like in no time. People just really grabbed that technology and then made their own versions of it. And it spread like wildfire. So one of the reasons that it all evolved so quickly is from the start, it's been this like open source kind of activity. The code was put out there for the first web server within a year of it being invented, and then people just took it and made their own, web servers, kind of extended it and improved it, and it just grew so fast. And that's one of the cool things, I think, about this whole industry, this like mass collaboration that we have with people all over the world, just taking code that other people write and making it their own and using it to make other cool things. And that's really kind of a neat thing, I think. So if you look at some of the statistics, so the World Wide Web Wanderer was the first automated spider. So this is something that just kind of like goes out, this sort of script that goes out to all of the endpoints that it finds on the World Wide Web and just collects some information like how many, that here's a new host, here's a host, and what kind of websites pop up, on web servers. And so it was deployed between 93 and 95 to collect some data. So here's some of the data that it collected. So in June of 1993, it found 130 websites. Can you imagine a world with only 130 websites? That's hard to imagine, isn't it? And there were 13,000 hosts per web server. So by December of 93, that number had grown, by more than 5 times. 623 websites it found. 6 months later, there were almost 3,000 websites. 6 months after that, over 10,000 websites. 6 months later, that number had doubled, and then 6 months after that, 100,000 websites were found. So it grew so fast, People really did take hold of the technology and had fun with it. So yes,
host per web server thing?
The host per web server is I'm trying to remember now. It's host per web server was, let's look because I can't remember what it was. I got this from here, I think. No, not from there. Let's look up. Maybe I don't have it linked here. So the World Wide Web Wanderer. All right, so let's see. counted only web server. Then it started to capture URLs. Okay, where 1 in every 270 machines on the internet is a web server. So this is how many machines were web servers. So by
because the machines got more powerful. Is that right?
and then more people just implemented web servers. So at the start, only 1 in 13,000 were web servers. So those, there were people like using the web servers or accessing the content, but only 1 in 13,000 were web servers. And by
so it'd be like one web server had 13,000 people on that one web server.
Yes, exactly.
And the next one would be they
Yes.
split that up, so there's more web pages.
More
and
web
each
servers.
web
Yeah.
server computer
exactly.
only had 3,000 people on that using that attached to that computer.
Attached to that computer. And by January of 96, for every 94 people, there was a web server. 94 computers using, there was a web server. So the growth of the number of web servers was incredible too. Like, the people using the internet, creating websites, grew, but also the number of people providing web servers to host that content grew really fast in that amount of time. So at the end of 1995, I mentioned there were an estimated 16 million internet users. Over the next 3 years, that number pretty much doubled every year to 147 million in 1998. By 2005, there were over 1 billion users, and that number tripled in less than 10 years, with an estimated 3 billion users in 2014. So the latest estimates by the Internet World Statistics Group is over 4.3 billion users exist today. So that's over half the world's population are Internet users today. And that's less than 20 years after the invention of the World Wide Web. So that's pretty staggering when you consider all the technology and infrastructure that's required to use the World Wide Web, that more than half the world's population uses it. Yes. Yeah, it includes China. That's right. So there are a lot of places in China that are rural. Yeah. Yes, that's true too.
I was reading a novel and the author wrote, and he can even use the internet. Like it was a privilege that he needed to have.
Yes, things are different in China for sure. So you can look here. So this is linked in the slides. You can see the growth in traffic. So this is in petabytes of data transferred per month, and this graph stops in 2011. So back at the beginning, at the start, we had 5.4 petabytes, which is a lot of data, sort of in 1997. But you can see that grew really fast. We went from 5.4 petabytes in 97 to 3 years later, 100 petabytes a month. And a petabyte is
1,000 terabytes.
1,000 terabytes, which would be 1 million gigabytes. A million gigabytes, yeah. That's a lot. So in 2011, 27,483 petabytes a month. That's a lot. That's a lot. I know. It must. It's
like Netflix and that.
It must be massive. Yeah. It must be massive. The growth is unreal, really. So besides the use, of course, with the use, the technology has grown and changed a lot over the last 20 years. And so there's, in this other view, you can see the introduction of the technologies at different times. So HTTP, created back here in 91, and then HTML first introduced sort of at the end of 91, and then we have the first browsers, so we had Mosaic at first, and then Netscape in 94, Internet Explorer in 95. Here you see the introduction of JavaScript, and here's HTML3 down here. This graph doesn't show HTML5 because it only goes to 2012, but I'll talk about when that came around. So you can just kind of, you can see that a lot of things have happened here. CSS3, you can see, so there's CSS2. I'm going to talk more about it in a second. But CSS3 actually has been around for a while, since the 2000s. So there have been evolutions in the protocols and the standards and the technologies and the tools. Definitely has made a change, right, in the way that we deliver content and the kind of content that we see and have available. Like, you wouldn't have had streaming video, until there was technology that enabled it being cheap enough for us to be able to do that, and fast enough, for it to be something that people would want to use. Just as an example, so in the early internet, you didn't put images on your pages because it would take forever for the page to load, and that's not a problem anymore. So one thing that's interesting to look at is the Wayback Machine. It's pretty interesting. Has anybody ever looked at that? Yeah, it's just an internet archiver, so you can look at web pages. Yeah, from different points in time. There are a couple. What did I do with them? There are a couple that I found that I thought were pretty good. Here we go. This one from Microsoft in 2001, and from Apple in 2001. So here's the Microsoft site in 2001.
Yeah.
That's pretty shocking, isn't it? Let's look at it now.
It's not unfamiliar to me, though.
So this is what it looks like today, right?
Very nice.
Really nice. This, yeah. Here's the Apple site.
The new iBook.
The new iBook. Yeah, Apple was always a little bit ahead of their time as far as like the way but these rounded corner tabs. Yeah, that's something. That's something.
10 years from now, Microsoft
So the Apple site today, so that's different. This is what really kills me about the Apple site, like this.
The rounded tabs.
The rounded tabs.
Yeah, it's so not classy.
That's pretty awful.
But look at the brick of the computer.
The new iPhone
Yeah.
is packed with
Oh,
classy
yeah,
touches.
Ethernet.
Yes.
Hot
starting
news.
at $1,300.
Hot news headlines.
Yes. I thoroughly enjoyed my time with my new iBook.
Get ready for Tomb Raider Chronicles.
Yes. Yeah, so TFT display, 5-hour battery. Like, that's probably better than what I've got. Airport ready.
IMDb.
Yeah. I don't know. I don't know what that means.
CD, right? DVD. You could put a DVD there and play it.
You
That's
could.
your best.
Yeah. Yeah. So it can be fun to look through the Wayback Machine, and so you can like click on these different times. Now some of these like won't be any good, so sometimes you have to click through, because sometimes it won't be. There's not that much earlier here. We'll try. So this is a little bit later. This is in 2005, but we still have the rounded tabs up here. Like, come on, Apple, get your stuff together.
Oh yeah, that's what you want.
1998. Look at that. Yeah. Blow minds, not budgets. Yeah.
Getting you Mac for $99. What?
Yeah, so that can be some good fun to look at.
Checking the old school.
I don't know what happened here. This is weird.
My dad from Wayback had one. This guy
Okay, so you can have a play around in the Wayback Machine, and you can look at what you got there. So in this class, we're going to be learning about the HTML5 and CSS3. That's what we're going to be learning. So HTML5 was first released as the W3C recommendation in 2014, so it's been around for a bit. And because it took so long for CSS2 to be accepted, it took 9 years from the time it was put forward to the time it was accepted. And that's because it had, like, parts of it had problems, and it held up the acceptance of the whole standard. So the decision was made to modularize all future versions of CSS. So from CSS3, we released these like modules, and the modules can get accepted on their own. So it wasn't until so CSS3 was first released in 2001, but the first modules didn't reach recommendation status until 2011. So obviously other things hold back the acceptance, the recommendation of CSS. And I'm not sure what it is that causes that problem, but obviously there's something. So you have to sort of be mindful when you use particular CSS properties that they may not all be in recommended status, and they might not all be adopted by every browser. And so you can use this W3 Schools resource is a good one to use to look up to see if a particular CSS feature is supported by a browser. So, it'll show the CSS properties, and then it will let you know on the right-hand side here. If it shows up, then it's supported at the minimum version that's shown for that browser technology. Okay? So one thing that's important to do when you're a web developer and you develop apps is to make sure that your apps work on the browsers that you want it to be supported on. So just because it works in Chrome doesn't mean that it works in a particular version of Internet Explorer or Safari or Firefox. Yeah, Jai?
If anybody's still using Internet Explorer, I don't want to use one.
Do you know what, though? Most of the world uses Internet Explorer. So as a cool kid, we know that you shouldn't use Internet Explorer, but I can tell you that the majority of the world uses Internet Explorer. So that's the reality of life. It's something, as a person who's always been a Unix user and I'm a little bit of a Windows bigot, which I'll admit to a lot of times, I've never been a big fan, but it's just because of the way that I grew up in technology in my career. But I've always resented that people use Internet Explorer, but they do. So that's the reality. So you can resist it, you can be like, well, that sucks, but that's how it is.
It's not about choosing to use Internet Explorer. They haven't chosen to use a particular Explorer in the default on Windows machines.
That's right. It's that the majority of the world uses Windows. And on Windows, unless, a lot of computer users don't think about what browser they're using. They use Windows. Windows comes with Internet Explorer, and that's what they use.
You can't even uninstall Explorer anymore.
No. Yeah.
Which really bothers me.
Yes. Yeah, so I can get into long conversations about all the reasons that I don't like Windows, and that's on the list. But what matters, though, is that if you're going to release something, and you have to think about who you're releasing it for, okay? Who your audience is, who your target audience is, and you want to make sure that your target audience can use your app, right? And that means that you need to test it on different browsers. And look, I think it's fine to say, okay, I'm only going to test it on the latest accepted versions of these browsers, the latest stable releases of these browsers. I've never been a person who had much patience for people who are using ancient browser technology. Come on, people, just update your damn browser, but you want to at least make sure it works on Internet Explorer, on Firefox, on Chrome, and on Safari for the Mac users that are using Safari and not Chrome. Okay. In addition to making sure that it works in, if you have a mobile app that's not running in a browser, making sure that it works on iOS and Android. So that means that's a lot of testing, but you can save yourself a little bit of grief by, for example, knowing that there are tables like this that will tell you which CSS works where. Same thing is going to be true for JavaScript. There are going to be JavaScript libraries that don't work everywhere. Okay? And we're going to use 6 JavaScript, and it doesn't work everywhere. So you have to kind of be aware of that too. All right? Okay, Wayback Machine. All right, so Varsha showed a slide that's prettier than my slide, but that's okay. That showed that we have a client, anytime that we have an interaction over the World Wide Web between two machines, we have a client and a server. The client sends requests to the server, and the server sends responses to those requests, and it's using HTTP and TCP/IP. I'll talk more about that on the next slide. So the clients are just internet-connected devices, like Varsha mentioned. Could be an app on your phone, could be a browser session on your laptop or on your phone. The servers are the content providers, and they're also connected to the internet. And they serve up the content. So the transmission control protocol and internet protocol, we usually say those things as one thing, TCP/IP. It's actually 2 separate protocols, but they work so closely together that we just kind of think of them as a single thing. But they are the communication protocols that enable information to move across the internet. So they are the things that dictate this is what data, the format that data is put in when it goes over the internet, so that a client knows how to send it and a server knows what it's getting when it gets it and how to understand that thing, how to understand that information. HTTP is an application protocol, the Hypertext Transfer Protocol, and it tells clients and servers how to talk to each other. So it tells the client how to send information or what to expect from a server in response to sending information. So we have certain status codes. That's a part of HTTP. Things like 200 status code means that it's okay. 404 status code means that something's not found, that the server couldn't find the thing that you asked for. And so there's some really some nice sites like HTTP status dogs. Do you guys ever use this? It's adorable. So there's a status dog for every HTTP status. Partial content. Oh my goodness. Partial content. Yes. 206 partial.
Oh, no.
Yes. Yeah. So, yeah. Already reported. 208.
300.
Yeah. Multiple choices.
What's 226?
I am used. Yeah. Not modified.
305. 305.
Yeah. Yeah, use proxy. So this is a kind of a fun way to look up HTTP status codes. And and get familiar with them.
And
Look at the bad request.
You
The
402.
dog's eating the couch.
Permanent redirect, yes.
Full seated.
It's pretty, request timeout. Oh my goodness. So, forbidden. Oh, forbidden. Oh, so adorable. Not acceptable.
For a non-conflict.
Proxy
Authentication
required.
required. Yes. Proxy authentication required. Yes.
411, length required.
Yes. It's pretty adorable.
What the hell?
It's pretty adorable. Request URI too long.
Requested range not.
Requested range not satisfiable.
On 13 requests.
Too many requests. Too many requests. Upgrade required. Oh no. It's really cute. Request header fields too large. Oh my goodness. Yeah, so that's pretty adorable. Anyway, those statuses are one thing that are part of the HTTP protocol, that application protocol. So, and then there's DNS, which are domain name servers, and so those act as an address book. You're probably familiar with those already. So those map human readable names to IP addresses, which are not very easy to remember, especially IPv6 IP addresses. So within each of these things, there's whole universes of stuff going on, okay? And you can study any of these in more detail if you're interested in it. You don't necessarily have to understand them in any detail to be a web developer, but it's good to understand that they're there and at play.
That's how they track the criminals.
So what happens when you visit a page on the web? So you go to a page in your browser that happens on the client. The browser goes to the DNS server, and it finds the real address of the server that the website lives on. So you type in a URL to your browser, it's going to be a name, like a human readable name. So the browser goes to the DNS server to get an IP address for that name. Then the browser sends an HTTP request to the server at that address, and it asks it to send a copy of the website to the client. That message and all the other data that's sent between the server and the client is sent across your internet connection using the TCP/IP protocols. If the server approves the client's request, then the server sends the client a 200 status message, and then it starts sending the website over in chunks called data packets. And then the browser actually takes all of these separate packets and assembles them into the content that you see in the browser. Okay? So it can't send it all over in one big chunk. That wouldn't work very well because it would tie things up on both ends. Okay? So that's why it sends it across in packets. And then there's the TCP/IP protocol manages how those packets are sent and that they get sent over and can be understood on the other end and put back into the right order. It handles things like packets that get lost, that are missing, resends packets that don't show up at the endpoint. All of that's managed in the TCP/IP protocol and the communication protocols. And there's a whole bunch of structure and understanding to how that actually works. It's pretty miraculous, really. It's all quite amazing that it works so well. When you think about the content that we use every day over the internet, I mean, it's fast, and it pretty much always works. You know, I mean, it's really, it mostly just always works. You know. So it's pretty amazing technology, and TCP/IP, remember, has existed since 1983. Like, so it was done well the first time, you know, and I mean, it has been built upon and improved and changed since then. But I mean, from the start, it was a really good, solid set of protocols. Okay, so that's it. There are some good links there, so you can do some further exploration. You can use these links also when you're answering those 3 short answer questions for your portfolio assessment. Okay, you should be able to find all the information you need to answer those questions. Feel free to look elsewhere.
Do you have to like reference like Harvard standards for the reference?
No, you don't. You don't even need to reference. Yeah. So I just put these here for your convenience, for those who don't want to go look around for the information yourself, but feel free, please, if you're kind of curious about it and want to learn more, feel free to go out and read more than what's provided here. This is still sort of like at the very top level of things. It doesn't, none of these go incredibly deep. Okay, any questions about any of that stuff? Questions? No? Pretty straightforward?